Okay, let's switch things up a little bit now and go from theory to practice. We're going to talk about some practical applications, specifically the four main forms that are used to document and set your standard work. So, the first one on this list is the standard worksheet. And this is really a top level view of how people and materials flow through the work area. The next one is the time observation sheet. And that is how you go about measuring the time it takes and getting your cycle times and determining what your standards are in your standard work. So this is where you go and determine exactly how long each step should take. And there's a lot that goes into it and how you don't just take an average. You have to figure out what the data means and understand the reasons that things were wrong, like higher or lower. So there's a lot that goes into this form. It's not just take the times and average it all out. The next form is called the standard work combination sheet. And this is a visual representation between people, machines, and space. And the space is shown via the walking time. So if you look over on this, over here, you can see this line here is automatic machine time, but these diagonals are when you're walking from step to step. So the longer steps, the form can sometimes be a little misleading if you put a work step and it's not broken down very much. It can look like a really long step when it's really maybe three or four smaller steps that could be broken apart. So you want to kind of decide how long you put for each of the steps that are in here. And like I said, there's a lot that goes into each of these forms. So we'll get into that in different lessons. This next form is the takt time calculator. And it is a tool that you use to figure out what your takt time is. And it lets you split your demand up by shift. It lets you remove any non-working time like meetings or lunches or breaks, things like that, and get a very accurate understanding of how long you have available for your time and then what your demand is so you can know what your takt time is. And that's your required pace of production. So now we'll dive into these in a little bit more detail. So this is a standard worksheet and um, it's a visual of the flow of the work and the people, and it's got a few specialized items in there. So at the bottom, you can see the little indicators for quality check, standard work and process, and safety. So that's kind of the big picture. You'll have a header in here, and that information will give you things like your tack time. So we do have a big focus on tack time, and this is important, but it's often neglected. And the reason why it's important is because you want to have a really clear understanding of what the standard work is that you're looking at and a good feeling for what the cycle time and attack time are, so you kind of know what the general pace is and what the requirements are for this work area. The um, layout and the path that go in there, it's not exactly a trace. It's more like a conceptual. You go from this station to this station, so maybe you have to walk in back and grab something before you go to the next station, and you don't show everything on there. The idea is to make it an uncluttered view that's fairly representative. So it's not something we're called a spaghetti diagram. We'll show that in a little bit. It's not a trace of the person is walking. It's a representation of the steps in terms of the flow that they have to go through. And the final thing in here is your standard whip. And obviously the standard whip can only move if a person moves, but you don't want to show extra stuff in there. So even though the person might be working on this as they walk through their whole process and they bring the standard work with them, you're just going to show it in one spot because you want to show how many items there are. And if there's any special cases, like we talked about earlier, where you have a machine and you have a piece of standard whip in there, or if you have two people working and some boundaries. So if you have more than one piece of standard whip, you want to show it here. Now, this next form is a time observation sheet. And the other forms are the visible forms, but the time observation might be the most important of the forms because it sets the standard. So all the other ones kind of show what's going on, but without this form setting what the standard is, you're never going to be accurate. And the form is really used to collect data, but the more important part about it is once you have this data collected, is how you can interpret the data. Now, the header information, like I said, it's again, it's always important and often neglected. And it's good to be able to go back and check in with people. So when you took it like this form, you see a spot where It says observer over here and the observation date. That lets you know if you're looking at the most recent one, and it lets you know who to go back and talk to if you have any questions about what happened. Now, the process steps, like I said, you want to have these broken down enough that they have a usefulness to them. If they're too big, they're not useful. If they're too small, your time observation sheet, your standard work, it's way too lengthy. So you really want to make sure that it kind of matches, um, you know, equal increments of the size of your work. So if you have a 25-minute process, each step should be about 2 minutes. Some will be longer, some will be shorter, but you want to try and gauge it out to fit what you have on your workflow. It just makes it work better, and you'll kind of get that as you experience this and you work on this a little bit. Um, the other thing I want to say in that before I get too far ahead is that the process steps on your time observation sheet and your standard worksheet and your standard work combination sheet should all align. So you don't want to have a different sequence in each of those forms. They should all be the same. Now, this next one, when you fill this out, the top block is going to be your running time. So you don't want to stop your clock. If you're standing there with a stopwatch and you're clicking and stop, start, you get a bad time. So you just do your running time. When you start, it'll be 0. And then you'll keep going down. And then the bottom one will be your calculated time. So that once you figure it out later, you know that if the next time you take on this second line here is 32 seconds, and this was 0, now you know this is 32, and you just keep adding it all the way down. And there's a form I have that starts to calculate this automatically, but there's probably also different kinds of apps you can find out there that can do some of these things. But I like to keep things simple, and I like to keep things manual because it's a lot easier to just have anybody do it. You don't have to have specialized training once you have the form. So um, I prefer the manual scribbling with pencil. You can always go to computer later and update it, but the idea is you want to have people who are very flexible. You don't want any kind of computer issues to slow you down. And then the final part here is when I said that the more important part is not just to collect the data, it's to interpret it. And this whole block over here lets you figure out how you want to set your time based on the observations you took. So once you get your time calculated, or you get your time recorded and then calculate out the elapsed time for each step, you can start taking a look at it. And there's a lot that goes into this. Not for this introductory course. We'll be talking about this in different courses on how to use a time observation sheet and how to take time studies. But right now, you just need to know that it's not a average. You don't just average it out because then you get wrong on all of them. It's just there's always problems that come up or things that happened, and averages just mean that you're going to be wrong most of the time. So this next form is a standard work combination sheet, and again, this is a representation of how machines and people and space all work together. And again, I said space is because this walking distance is an indicator of how far apart your steps are, your work steps. It's kind of like confusing because steps is in walking and steps is in process steps. So if you're going from your taking orders to prepping lemons over here and you're walking this distance, there's a little bit of space involved. So that's kind of how this goes. Um, you have your header information over here. Same thing. You should have all the numbers should all match takt time, cycle time. This has a little bit more information on here, so you can kind of see the units per shift over here, and I'll help you understand takt time. And again, this is just a underused, or it's a very important but kind of underappreciated when you talk about the headers. Now, the process steps, again, these steps are going to be predetermined by your standard worksheet and your time observation sheet. You have your timeline, and like I said, you have your operator time, and then you have your machine time that's going to kind of go out there, and this is automatic machine time. So if an operator is running a machine here, it's going to overlap. You're not going to see a separate machine time. So a machine doesn't matter unless it's running independently. And the biggest reason why this really matters is if it's a long cycle and the machine runs over here to the end and you kind of wrap around, you can see how much timing you need to be able to get a person back to start the next cycle. So in this case, if it's 90 seconds, if you have an 83-second machine, you don't have a lot of window of opportunity. If you have a 95-second machine, it doesn't work fast enough to keep up with your pace. Then you have your takt time, and this is very important. The takt time is normally drawn in red, and it shows the limit. So in this case, you can always see that, and you come back over here, and there's kind of the waiting at the end over here. So some of these are a little hard to see here. Apologize for that, but this would be a waiting time. So when you finish up, you go back to the beginning. Um, so that's how that works. Okay, this next form is the Takt time calculator. So on a Takt time calculator, this is a tool that helps you determine your required pace of production. And it's one of the things that I like to stress is that takt time is calculated, cycle time is measured. So cycle time is how fast you can do it, and takt time is how fast you have to do it to meet your customer demand. Now, what this tool does is it starts out with your shift time, and you're going to know how many minutes you have and whether you want to use your lunch time in here or not. If you do use lunch time as part of the total shift time, you'll have to take it out later, and that would be in the non-working time. So if you're giving lunch as part of the shift, you take your 30 minutes out or an hour out, whatever it is, but you take out all of your other stuff in there. So the time you have people working to get started, turning their machines on, warming them up, getting the tools ready, doing safety checks, all those kind of things. It's the startup time, maybe a morning stand-up meeting, afternoon break. All that stuff comes out of the total time that's available, and you need to make sure you pull it out to get an accurate time. And that gives you the overall available time. And with that, you can do the calculation with your weekly demand. And if you have the number of shifts, you can kind of figure out the demand per shift. So your demand of 100 in 5 shifts, your demand per shift is going to be 20. And then you can calculate it out knowing that you have 435 minutes and you need to get 20 pieces done. That's what your time comes out to be. And you have a number of seconds that you have to get each one done. So that's how you calculate this out. Now, those are the 4 main forms. There's also an additional form or a couple of additional forms that we often see associated with standard work. And the first one is the spaghetti chart. Now, the spaghetti chart follows a person's route. And like earlier when I talked about the standard worksheet, I said it was not a overhead view of a trace of the person's footsteps. This is a trace. And what I like to see with this one is you see a person go and do their work. You can kind of see if there's a piece of the area that they're not very well organized. If they're walking back and forth a lot, or if they're kind of going squiggles or long distances, it really becomes apparent when you do this exercise. And the other one is the operator load chart. And this is how well you balance your work. And there's a lot of thought that goes into this. I never like seeing it where it's really like a lot of the spaces all lined up. There's a thing called the least operator concept. And this is where you have each person at the front is fully matched to their cycle time and takt time are matched. And the last person would have a lot of extra time. It frees up a lot of opportunity to have a person that can bounce over to help other people if they only have like half a line shift worth of work. So that's all I got on this one. That's the end of the forms.